you find yourself in something that's totally massive and disgusting, like horrendous, probably something went wrong or there's an easier way to do it. Sometimes they have to explode and to get better, but not super amount. So 2 root x is equal to this one right here, 3x plus what? 4. What could you do at this point if you wanted to? What could you just do? The square root is already, you could divide by 2, but I'm going to show you something a little different this time. You could. Okay, so let's do it this way. You could. Either way, let's do it this way first. This is totally fine. And then you went like this. You like the denominator. That's totally fine. Now what's your only option? Square both sides. So you know that x is going to equal 3x plus 4 over what? 4, not 2, because everything has to be squared. Both sides have to be squared. Yep. So then you multiply both sides by what? 4, and you get 4x is equal to 3x plus 4. So you get x is equal to 4. And then after you do that, what's really important that you do? Check your answer. Does it check? It does check. Okay, there's another order we can do it in, but we'll do that in 1 sec. Yeah, you can. Now here's the thing. I'm doing it that way because that's to remain consistent with how we did it last week. You could at this point just square. If you square both sides, what do you get? You get 4 times x equals 3x plus 4. You can square both sides because you just have to make sure you square this and that because they're multiplied together, and then this gets squared so the root goes away. And do you end up with the same thing? Yeah, absolutely. Just be careful. Just be careful. Just make sure you square that too. It's really common for kids to be like, oh, 2 root x squared is 2x. No, it's 4x. You have to square both of them. Both of them. So then you guys asked about, let's do this in descending here, 20, we'll go up. 23, we'll just run the ladder here. 23 says x equals the square root of x squared plus 4x minus what? 20. So what do you have to do to both sides? Yeah, it's the only thing you can do at the moment. So you end up with x squared is equal to x squared plus 4x minus 20. What's nice about this setup? They go away, and you're left with 0 is equal to 4x minus 20. So 4x is equal to 20. So x is equal to 5. And what's the best thing you should do at this point? Yeah, well, it's going to be negative 4x equals negative 20, which is the same thing as 4x equals 20. You have to check it. And does it check? Let's try it. The square root of 25 plus 20 minus 20. Well, those go away. That's the square root of 25, which is 5. So it does check. It's really important that you check. When you start squaring as an operation, it's really easy to generate false answers. Next one, what? 27, I think you were asking about? 27? 27 gets a little bit more fun. Okay, the square root of 9 minus x is equal to x plus what? 3? Well, what's that first word for these that I liked you to, it begins with an I? Isolate, remember that? Is the radical isolated? Yes. Yeah, so what's your only step at this point? Yeah, so you end up with 9 minus x is equal to this squared. What's the really common mistake at this point that sometimes people make and I get real sad, and then they just go, they square x plus 3 squared by just making it x squared and 3 squared. Is that correct? No. Really, no. So you end up with 9 minus x is equal to what? X squared plus 3x plus 9. I'm just combining them together. Now, what kind of equation is this? This is a what equation? Yeah, it's a quadratic, so we want to set it equal to 0. So you end up with 0 is equal to x squared plus how many x's? 7x, but then what cancels on both sides? 9. What can you factor out of this? X times x plus 7, so there's 2 answers. X is 0 or what? Or negative 7. Negative 7. So at this point, what do you have to do with both of these answers?
Can you go through the 0 equals x?
Yeah, because look, you know when you're at this point right here, you have 2 things multiplied together. You have this thing and this thing multiplied together equals 0. In order for 2 things to multiply together to get 0, one or both has to be. So this has to be 0. How do you make that 0? Well, no, it's x. How do you make x 0? You make it equal to 0. How do you make x plus 7 equals 0? X is equal to negative 7. So that's where these 2 come from. But now what do you do once you have these 2 values? You better check them, because one of them really isn't going to work. X equals 0. The square root of 9 minus 0 is the square root of 9, which is 3. And what's it going to be on the right side? 0 plus 3. So does 3 equal 3? Yes, it does. What about this negative 7 thing? If x is equal to negative 7, you end up with the square root of 9 minus negative 7, which is the square root of what? Which is what? Just what?
It's like 2.5.
No, what is the square root of 16? 4. Just 4. It's not negative 4. Yeah, it's, oh yeah, you're going a little further. Now on the other side, what do you have though? Negative 7 plus 3, which is what? Negative 4. Those are not the same, so which one is not a proper answer? Negative 7 doesn't work, so what's your only answer? 0. Only answer. You need to make sure you check them. Or is there anything floating out front? Are there any coefficients? Is there anything being added? No. So really, what's the only thing you can do at this point? Square both sides. So if you square both sides, what does the right-hand side become? 4x plus 2, right? What does the left-hand side become? 2 square roots of x plus 11. Exactly. When you square it, just this one goes away. Oh, wait. Now are we pretty much back to where we have been before? Yeah, what could you do to both sides right now? You could divide by 2, or you could just what? You could. Dividing by 2 kind of is nice here because everything is even, right? So if we divide by 2, what do you end up with? The square root of x plus 11 equals what? 2x plus 1. When you can do that, do it. Now, you square both sides properly, and you end up with what? X plus 11 equals what, Kelly?
Isn't there a 4?
No, there isn't, because when you square this, it gets rid of that radical only. It doesn't touch that 2 yet.
Yeah, but then you just square it again.
No, we divided by 2 first to turn that into a 2 and to turn that into a 1, right? So now we square it and you end up with x plus 11 equals what, Kelly?
4x squared
yes.
plus 2x plus 2x
yep.
plus 1.
Correct. And now, what kind of equation do we have?
Quadratic.
So we need to make it equal
0.
So we do have 4x squared. We have 4x on the right, but then we take away an x, leaving us with what? 3x, and then it's going to be minus 10. Now at this point, unfortunately, the leading coefficient is not 1. What is the leading coefficient right now? 4. We're not super happy about that, especially since 4 could be 4 and 1 or 2 and 2. But it could be worse, right? So what do you have to try to do at this point? Factor, right? So do that right now. See if you can factor this for me. Don't say it out loud. Just see if you can factor it for me by yourself. We have x plus 2, yep.
Times 4x minus
4x minus 5. Yeah. Anybody agree with that?
Yeah.
What do you have to do to see if this works? You have to test it, right? What do you end up with? 4x squared minus 5x plus 8x minus 10. Is that what we want it to be? It is what we want it to be. So it does, in fact, work. So how many things do you have multiplied together? You have one thing and two things. So either x plus 2 equals 0 or what? So therefore, x is equal to negative 2, or 4x equals 5, so x is equal to? So we won't do it right now, but what would you, as I've said many times, what do you do with those two things?
Plug them back in.
Plug them back in. You plug them back in. You plug them back in. You plug them back in. So this is a type of question we did last week that I want to make sure that you shake out a little bit here. On this one, what's the difference here between this one and the ones we've done before? Yeah, there's multiple radicals, right? So what did I tell you is a good thing to do before you start? What? Yeah, isolate. Put them all on one side. So which one do you want to move? The first one or the second one? Yeah. Why did you choose the second one, Kelly? Positive, right. So you end up with 1 plus k minus 3 like this. Now, what's the only thing you can really do at this point? Square it. So how about you try this? So what does the left side become? K plus 2. And then the right-hand side, remember it has to be 1 plus root k minus 3 times what? 1 plus root k minus 3 because you're squaring both sides. So you end up with k plus 2 is equal to, what's 1 times 1? 1. So then you have plus root k minus 3 plus root k minus 3. What's the last thing you have here? What's the last thing you have? Okay, once again, we're just foiling, right? Is this a new thing? No. This is not a new thing. We did 1 times 1, right?
Yeah.
Then we have 1 times that. What's 1 times that going to be equal to? The same thing. So it's going to be the square root of k minus 3. But then you have this, which is the same thing, right? But then what's this times this? What's the square root of k minus 3 times the square root of k minus 3? It is k minus 3. Because the square root of a table times the square root of a table is what? So at this point, what should we do? What do you think we should do at this point? Combine like terms. Exactly. Combine like terms. So what does the left... Oh, it stays k plus 2 equals... We have 1 and negative 3. So what does that become? Minus 2. And then we have 2 of these. So what do we write? 2 root k minus 3. And then what's left? Plus k. Now, is there something we can cancel on both sides? The k cancels. And what can we divide everything by?
2.
So what do we have now? 1 is equal to negative 1 plus root k minus 3. How many radicals do we have now? We have 1 radical. So what's that word? What's that first word? Isolate. So what do we do to isolate the radical? Yeah, so you get negative 2 is equal to this. Oh, I can almost do basic math. Almost, kids. What do I do to both sides? 4 is equal to? So what does k equal? 7. Now, what do you do once you have that 7? You plug it in over there. So it was, if we test k equals 7, we have the square root of 7 plus 2 minus the square root of 7 minus 3. That's the square root of 9. The square root of 4. That's 3 minus 2, which is 1. So does it check? Yeah. It sure does. Put everything away except the pencil. So the first definition, and really the only new definition today, is what's in the red box right here. So I'm going to write it real big for you. The square root of negative 1 is defined as this new number I. This new number I. Oh, so tough. Suck it up. Suck it up. The reason you need this unit, called the imaginary unit, is we need to be able to work with numbers that we've actually seen before, things like the square root of negative 4. When we thought about this, we're looking for a number that multiplies by itself to get negative 4. But you know that any number times itself is positive or 0. So when we say any number, we mean any real number. So we now get to work with imaginary numbers, and every imaginary number is going to have an I as part of it. It's really ridiculously straightforward. It is a self-fulfilling prophecy completely if you think this is hard stuff. If you think this is going to be really hard, it will be. I can guarantee that this is about as straightforward as it gets because all of the mechanisms revolve around these two things. I is the square root of negative 1. So what does that mean I squared is? If you remember this and always use this, you'll be totally fine. You'll be totally fine. So why does this help us? Well, this helps us because now we can say that this is equal to the square root of 4 times the square root of negative 1. We know that because you can break apart negative 4 into 4 and negative 1. Well, what is the square root of 4? 2. And what did we say by definition the square root of negative 1 is? 2i. So we now know, and we can write, the square root of negative 4 is equal to 2i. How do we test this to see if this is true? Well, we know that the square root of 9 is 3, because 3 squared is 9. So let's try squaring this. 2i squared. Well, that's 2i times 2i. What's 2 times 2?
4.
And I times I is just I squared. But what is the definition of I squared?
Negative 1.
Negative 1. So now what do we have? 4 times negative 1 is... So does that check?
How can I...
Stop for 1 sec. Does that check?
Yeah.
Yes, absolutely. It absolutely checks. Just in terms of the geometry of imaginary numbers, we have looked so far at all numbers that exist on this thing. We've called this the real number line, right? Any number that we've talked to up until this point lives somewhere on the real number line. 2, 4, 7, negative 7, pi, the number e. You haven't heard of that before, but they're all on this line. Are imaginary numbers on this line? No, they're not. I'm going to tell you where they are, but they're not on this line. They're not on this line. We know that the square root of negative 3 is the square root of 3 times the square root of negative 1. By definition. We know that the square root of negative 7 is the square root of 7 times the square root of negative 1. No, it's not. Just be very careful. What is the square root of negative 1? What did we say that is? That is I. What is this? I. So now what do we have? We have I root 3 times what? I root 7, What's I times I? I squared. And what's root 3 times root 7? Root 21, right? But what is I squared? This is negative 1. So what do you end up with? Negative the square root of 21. That's what it is by definition. You have to be very, very careful about this. So over here, what would the answer be? Just take a look at it. You don't need to do it out. What do you think the answer would be? Negative what? The square root of 16. So this answer would be negative what? 4. And the reason for that, let me actually get this out here, sorry. Get this. The reason for that is, if we did out the steps, sorry, I'm going crazy with the pens apparently. If I move this down, we can do the same steps. This is going to be the square root of negative 1 times the square root of 2 times the square root of negative 1 times the square root of 8. But what is the square root of negative 1 by definition? This is I, and what is this? I. So you can do the same work we did before, and what do you end up with? I squared times the square root of 2 times the square root of 8. What's 2 times 8? But what is I squared? And what is the square root of 16? 4. So you have to do this very, very carefully. That's the first moral. Square root of negative 3. What did we say we could factor out? It's going to be the square root of negative 1 times the square root of over what? Square root of what times square root of 3. So if we continued with this, let me make sure I have another example lined up. If we continued with this, what does it look like we could do? Anybody? What could you do? Oh, wait, what do you see in the numerator? And can you cancel? Yeah, even it doesn't matter what they are. If it's the same on the top and bottom and it's multiplication, can you cancel? Absolutely. So just take a pause. We're now at the square root of 75 over the square root of 3. Which one can we simplify, the top or the bottom? Absolutely, because the top is the square root of 25 times the square root of over the square root of what cancels? You're left with, which is what? Did that work out kind of nicely?
Yes.
It did. It did. It looked like it was going to be terrible. Does it have to be terrible, I guess is what I'm getting at. No. What happens if I gave you this one, though? Negative 32 over the square root of 8. What's the key difference between this one and the one we just did? Doesn't have two negatives. So on the top, what can we pull out first? The square root of negative 1 times the square root of over the square root of. Well, what is the square root of negative 1? So we have I root 32 over the square root of 8. And this is where we need to do the math we already know about. We need to take this and simplify. What can we do to simplify this? You could, absolutely. That is totally valid. The only reason I'm hesitating is that you then have to multiply 32 times 8, and I want to try to avoid that. What can you do if you have these radicals over themselves? You could, but you could also combine them and make it the square root of, like that. Remember how you can put it back together? The reason I do that is because what's 32 over 8? 4. So this is I times the square root of 4. What is that? 2i. Exactly. Exactly. See what I mean? You could do that. That's fine. The only reason I did it is you're like square root of 240, 250. Oh, it works. But this is a little bit more straightforward. Like every number that we've thought of is a real number, right? What's one type of real numbers? Integers. What's another type of real numbers? Whole numbers, right? Odd integers, even integers, right? There's actually a bigger set that we've thought of real numbers as being the whole encompassing set. There's actually a bigger set that real numbers are a part of. There's this big set, and it's called complex numbers. And inside the complex numbers, there are real numbers, and what are the other ones? Imaginary numbers. So inside the real numbers, we have a ton of sets. We have rational numbers, we have irrational numbers, we have integers, we have whole numbers. But there's this whole other side. The big family, though, they are called complex numbers. All complex numbers have this form, and you see it right here. It is a plus bi. This is the real part, and this is the imaginary part. We've actually been dealing with complex numbers the entire time. What has been our b value up until today? What has our b value always been? Have we had any imaginary parts yet? No. So what does b have to be to make the I go away? 0. So up until today, our b values have always been 0. What I'm telling you is now they are not always going to be 0. They're not always going to be 0. So what, try to write anything down. What does that equal? Come on.
2 plus
8.
8 plus 7i.
Done. Nothing changes. The same rules exist. The same exact rules exist. But here's the thing. This is one complex number, and this is another, and you made a third. So now we're going to add 3 of them together. What are the real parts to this one? 4 plus 3 is? 7 minus 6 is? 1. You with me so far?
Yes.
And then what do you have here? You have 2i, 1i, and so what do you have? Plus 4i. Done. Nothing changes about the mechanics for adding and subtracting. Nothing at all. The only thing that changes with multiplication is what is I times I? Which is? -1. Go back to this. You have to remember this block right here. Right here. What is I squared equal to? That's the only new thing, really, that you have today. Really, that's the only new thing. Not. Well, what's 4i times 2?
6.
No, 8. Come on, 8i. And what's 4i times 3i? But what is I squared? So it's 8i minus 12. And generally speaking, even though that's pretty clean, what do we like to write first, the real part or the imaginary part? We like to write the real part. So generally speaking, you would see it written like this. But you would be done at that point.
Would you like to factor?
No, leave it like that. No, if I wanted the final answer for a complex number, leave it like this. What about here? What do we have to do? We're multiplying. We have to use what? FOIL. 3 times 4 is? Minus 6i plus what? 20i minus how many i's? 10. Well, what's this? Let's combine that. What's negative 6i and 20i? 14i minus 10 times. But what is I squared? So it's 10 times -1. So you have 12 plus 14i plus what? Oh, 12 and 10 is? Plus 14i. Done. Don't factor. Leave it like that. You're done. Nothing new. This is basic algebra with one added bonus. What's I squared equal to? It's with this nice bonus where it collapses a lot of the time. So will it get, what did I tell you about? You don't really like having square roots in the denominator, right? Similarly, you don't really like having imaginary numbers in the denominator. So you have to multiply this by some form of 1 so that you end up making the denominator real. Again, do you care what the numerator does? Not really. But you can only multiply by a form of 1. So what do you think you're going to multiply by? And careful. What do you think? It's similar to what we did before. Close. Close. Nope. Nope. We did this before, but with no. We did an example like this with rationalizing denominators. Okay, let's try this here. Let's say you multiply by 2i. No, look, hold on. Let's try it. Let's see what happens, right? Our goal is to get rid of I in the denominator, right? Yes, 2i times 2i is 4i squared, which is -4, right? But you also have to multiply the 2i times the 5, which leaves you with 10i. So this is close, but it's not there. What do you think you multiply by? Oops, sorry. Ooh, there it is. You got it. You multiply by 5 minus 2i over what? 5 minus 2i. This right here is just a fancy form of what? That's just a fancy form of 1. Exactly. That's all it is. But when we multiply this out, what does the top become? What's 8 times 5? 40 minus, what, 16i? Plus how many I? 45i. Minus how many I squareds? 18i squared. What does the bottom become, Dev? 25 minus 10i plus 10i minus
4i squared.
Yeah, what's the cool thing that cancels in the denominator? Those go away, and what are you left with? 40 plus how many i's? Yeah, we will. What's on top? What's 45 minus 16? 29i, right? Minus what, 18i? All over 25 minus, oh, is that squared right there? Thank you. So it's going to be, I'll do it in steps. I don't want to skip at this point, so I'll try to be careful about that. You end up with minus 4, but what is I squared? So I can replace the I squared up here with what? Negative 1. So what does the top become? 40 plus 18 is 58 plus 29i. What does the bottom become? 25 plus 4, which is what? Can this be simplified? Yeah, what does it turn into? 58 over 29 plus 29i over 29. Done. Kill. Yeah, I over I. And when you multiply that, what do you end up with? I plus I squared all over. But what is I squared? So you have I minus 1 over. So that's going to simplify to negative I plus 1. And in general, you like to put the real part first. So the best way to write this would be 1 minus I. Does anything change? No. But we already know that I squared is equal to what? Negative 1. So let's talk about I cubed. That's the same thing as I squared times I, correct? But what is I squared? So that's negative 1 times I. What's negative 1 times I? Negative I. What about I to the 4th? That's I squared times I squared, correct? What is I squared? So that's negative 1 times negative 1, which is 1. So what have we figured out so far? I to the 1st is I squared is, I cubed is negative I, and I to the 4th is 1. So the next thing I'm going to ask you is I to the 5th. Well, we know that's I to the 4th times I, correct? What is I to the 4th? So that's 1 times I, which is I. So I to the 5th is I. Oh, look at this. I to the 6th is I to the 5th times I, right? So that's, what is I to the 5th? I times I, which is I squared, which is, oh, so do you see a pattern? So what do you think I to the 7th is going to be? Negative I. And then I to the 8th is 1. So look what happens here. It repeats every 4. It repeats every 4. You see that? So the reason this is helpful is because you might sometimes run into this. I could ask you I to the 12th. What do you think I to the 12th is going to be? Well, it's what do you think it's going to be? 1. It's going to be 1. Every time you add 4, look. 1. What's 1 plus 4? Kids, what's 1 plus 4? 5. 5 plus 4 is 9. So I to the 9th would be I, right? So you have to look at the original 4 and see where it adds up. You have to look at the original and see where it adds up. So 12, if you work back from 12, what's 12 going to go back to? Right here, correct? Yeah. Subtract 4. So then you could get even more fun. I could say, what is I to the 59th power? How do you figure out, what simple division do you have to do to figure out which that goes through? It's only 1 of 4 answers, right? Correct. You do 59 divided by 4. What is 59 divided by 4 going to be? Oh, come on. What's the closest multiple? Well, 4 times 15 is, so it's going to be 14 and 3/4. 14 and 3/4. So which one do you think it's going to be? Negative I. Very good. Because if it goes in evenly, let's test this out and see. There's a way we could do this pretty nicely. We could break it down again. Well, we know that we know it goes in 14 times, right? So you're going to have I to the 4th how many times? 14 times, right? Correct? You're going to have I to the 4th 14 times. And I'm going to write this properly here. So you have 14 and 3/4. Like this. So we know that I to the 59th is going to be, I to the 59th is I to the 4th how many times? 14 times, correct? But then what's left over? I to the 3rd, right? Okay, but what do we know I to the 4th is? Oh, what's I to the 4th? 1. So it's 1 to the 14th times I cubed, right? But what is 1 to the 14th? 1. So this is just I to the third. But what is I to the third? Negative. I to the third is what? Negative I. So here's the thing. I to any power can be only one of four answers. What could it be? It could be I. It could be 1. It could be negative I, or it could be negative 1. There's only four possible answers. Okay, sit down. So 39 over 4. Just to remember, what is that going to be? It's going to be 9 and how many? 9 and 3/4. So it's going to be the third one. So which one is the third one?
Negative I.
Negative I. So this one is just like the last one. This is...
Oh, wait, 39 goes into 13 goes into 3.
We're not doing 13. It's 4. So remember, 4 rotates every 4.
Oh.
So this is the new thing right here, and I just want to focus on it. What does to the negative 2 power mean, Katie? What does it mean when you raise something to the negative 2 power? It's 1 over I squared. What is I squared? So this is just... Exactly. This one's a little different. What's I to the negative 1 mean? It means 1 over I to the first. Do we like having I in the denominator? No. So Kelly, what do we multiply by?
I over I.
Correct. So you get I over I squared, which is I over negative 1. And what does that simplify to? I find this really satisfying, personally.
It's just like that. It's very
This is super. Ah, it is. That was nice. Excellent. I wish I came up with it on purpose.